This is my useless box. The first feature to notice is the main external switch that initiates the various reaction sequences of the box. The most basic reaction simply turns the switch off. To do this, there is a servo motor on the side that lifts up the lid and a servo motor under the switch connected to the main arm that turns the switch off. More complicated reactions make use of the PIR sensor shown taped to the open lid, the sonic distance sensor on the front, or the RC motors driving two wheels underneath. Something worth noticing throughout this video is the workarounds to deal with all the motors being too weak for the task assigned to them. For example, the servo motor controlling the arm is not strong enough to flip the switch, so a rubber band is connected to the switch to lower the threshold force required to turn it off. Similarly, the cardboard door is too heavy for the servo motor, so it is set to be mostly open, only requiring a small push to raise it high enough for the arm to come out. Next are the wheels. The wheels are each controlled by a separate low-speed, high-torque RC motor. Two ball casters are placed on the front to provide stability with minimal added friction. Unfortunately, these motors are not capable of handling the weight of the box, and so are unable to effectively move. Turning more than forward-backward driving is what is adversely affected. This will be demonstrated soon. With this overview in mind, though, I will now demonstrate the four main reactions of the useless box. The first reaction is a simple shutoff, as shown before. The second reaction is another straightforward shutoff, but with motion that appears to show frustration. The third reaction is to turn away before turning off the switch, and then wait and watch for a hand to approach the switch. If the PIR sensor picks up a hand, then it turns the box away and continues to look. You can see that the wheels struggle to turn the box, so it is mostly just readjusting itself. The PIR sensor remains high for 5 to 7 seconds, and then must be low for an additional 4 seconds before going active again. If the PIR sensor is active for enough time, it returns the box to a closed state. The fourth and final reaction is to drive forward for some amount of time and then turn off the switch. While driving, the sonic sensor looks for obstacles. If anything is too close to the front of it, then the box turns until nothing is in the way. Once nothing is in the way, it keeps going forward. To demonstrate that the wheels work as intended but simply lack the needed power and traction, I will go through the third and fourth reaction with a direct view of the wheels. For the third reaction that makes use of the PIR sensor, the wheels start off by rotating in opposite directions in an attempt to turn the box. If the PIR sensor detects a hand while active, then it again signals the box to turn. For the fourth reaction that uses the sonic sensor to drive forward while avoiding obstacles, the wheels rotate in the same direction until something appears too close to the sensor. Then the wheels rotate the box until nothing is in the way, and then drive forward once again.
Driving away, turning, driving forward.